لسلامتنا وسلامتكم اليوم. تعليمات السلامة في حال حصل إنذار. طبعا اليوم ما عندنا أي إنذار مجدول، فلو حصل إنذار معناته بيكون إنذار حقيقي. حاليا مكاننا احنا في المدرج هنا. يوجد مخرجين للطوارئ، هذا المخرج الأول وهذا المخرج الثاني. المخارج بالاتجاه هذا. لما نسمع صوت الإنذار نتوجه إلى أقرب مخرج للطوارئ. ما في داعي أبدا للسرعة، المشي يكون يعني بسرعة معقولة. اترك كل أغراضك الشخصية وغادر، ما في داعي تضيع وقت في أي شيء زي كذا. وتتوجه إلى الدور الأرضي ومنها إلى منطقة التجمع في الوادي في كافد. Welcome everybody. Hello and welcome to SIDF. For those who do not speak Arabic, these are some of the safety instructions that you need today. There is no planned alarm today test. So whenever you listen to or whenever you hear the alarm, that means there is a real emergency. We are here right now in the auditorium, and we have two emergency evacuation doors here and there. So if you hear the alarm, please walk. Do not rush anybody. Do not push anybody, and evacuate the building to the ground floor, and from there to the assembly point. We hope you a safe day, and I'll hand it over to my colleague Yasin.
حضورنا الكرام، السلام عليكم ورحمة الله وبركاته. يسعدنا اليوم الترحيب بكم في فعالية شهر المعرفة للثورة الصناعية الرابعة والصناعة الحديثة. فأهلا ومرحبا بكم، شاكرين لكم تلبية الدعوة لتوحيد الجهود ونشر التوعية في هذا القطاع. I would like to welcome you to the Knowledge November session on Industry 4.0 and modern manufacturing. Thank you for being a key part of the event to unify the efforts and spread the awareness in the sector. كما لا يخفى عنكم، تم إطلاق الاستراتيجية الوطنية للصناعة، والتي تهدف إلى مضاعفة المنتجات الصناعية السعودية 3 أضعاف، ورفع قيمة الصادرات الصناعية السعودية إلى 149 مليار دولار بحلول 2030. وبلا شك أن أحد أهم مقومات تحقيق الأهداف المرجوة هو استخدام مبادئ الثورة الصناعية الرابعة والصناعة الحديثة. As you all know, the National Industrial Strategy has launched and aims to triple the industrial output and increase the industrial exports to $149 billion by 2030. And of course, one of the key elements to achieve the goals is to use Industry 4.0 and modern manufacturing concepts. سنحظى اليوم في هذه الفعالية بفرصة للتبادل المعرفي بين بعض من قادة وخبراء المنظومة الصناعية والتقنية، بما يحقق التكامل المعرفي اللازم للازدهار الاقتصادي. لقاء اليوم ما هو إلا استمرار للجهود المبذولة من قبل المنظومة الصناعية والتقنية ككل. Today's event is a chance to share knowledge among some of the industrial and technological experts to contribute to the economical development of the kingdom. لكل تعاون من شأنه فتح آفاق معرفية وتشارك للخبرات للوصول إلى أهداف رؤية 2030 وبالأخص مستهدفات القطاع الصناعي. Our collaboration could open new horizons to help achieve Vision 2030 and especially industrial goals. أكرر الترحيب بكم من جديد، وسننتقل الآن لفقرات لقاء اليوم مع الزميلة أسماء العلياني. Once again, welcome. We will now move to today's agenda with my colleague أسماء العلياني.
Good morning, everyone. It's a real honor being here. Our guest speaker is a National Productivity Program Manager, an industrial engineer with over 7 years of experience in the Industry 4.0 and operational excellence. To know more about Mudin's program details and its support for digitalization of factories, please welcome to the stage Mr. Abdurrahman Al-Askar.
Assalamu alaikum. Good morning. صبحكم الله بالخير. I'm taking this opportunity while we're waiting for the slides to show up to thank Saudi SIDF for hosting such a great event to promote awareness through November شهر المعرفة. Once again, my name is Abdul Askar. I hope you can hear me very well. أنا أحب أتحرك وايد. My name is Abdul Askar. I'm from Mudun. I'm managing the National Productivity Program known as برنامج التهجير الوطني or NPP. Okay, so the program is aiming to focus on delivering 100 blueprints to existing factories. What does that mean? It means that we help our clients to adopt the latest technology through giving them a free consultation services from training, analyzing their current operation, and helping them to deliver initiatives that will upgrade their productivity, enhance their productivity, reduce cost, and be lean as possible. This program is fully funded by NIDLIB, and it's one of the 2030 Saudi initiatives to adopt Industry 4.0 technologies. Now we're working also together with SIDF and the ministry to extend the program to address 300 factories, inshallah. How we typically do the assessment. We start with 3 main phases. The first phase is preparation. This is where we prepare, conduct the training, gather the required data, and so on. The next phase is the diagnostic, then the design, and then the implementation. Unfortunately, implementation is not part of the scope yet, but inshallah it will be with the support with SIDF and the ministry as well. Let's go in detail. So in preparation, what do? We gather the required data, if exists. If not, we implement some of the proof of concept and pilots we will discuss in a minute. So what we do in the training session, we are linked and work together with digital capability centers internally and externally. These are some of the digital capability centers located in Singapore. We work with them closely to showcase the latest technology and how each factory can adopt such technologies and solutions. It's also an interaction session for 3 days where certain questions can be raised to those digital capability centers. They can also try some of the technology that has been used worldwide. So once we promote awareness, once the 3-day boot camp is conducted, we work together in the diagnostic, and this usually takes 3 to 4 weeks. What we do here, we conduct deep dive analysis on certain levers, and then we conduct theory assessment. The methodology that we follow, it's called triple transformation. We start with the business transformation. We look at the business assets. What are the levers that we can address in the business, meaning operation and so on. And then we look at the technology, what we can do to transfer their technology, whether it's related to ERP system, SCADA, MES, and so on. And then the last transformation, which is organization, what we can do or how we can help the organization from organization perspective. These are some of the deep dive analysis examples that we conduct to the factories. We look at the asset utilization, we look at the planning, how well they do planning and so on, inventory, label optimization, and so on. We cover the factory end to end. And these are some of the deep dive analysis that we conduct. Either it's improved sales forecasting by implementing some of the advanced planning tools. Some of the things that we do, and it really helps the client to understand that such technology exists, and also helps us as a consultant to understand what are the pain for each factory and the gaps as well. We implement some of the proof of concepts. Pilots, it usually takes half an hour to implement. So some of these pilots are either related to real-time digital performance management, or could be some of the analytics advanced tools. So in terms of digital management tools, we implement some of the IoT kits. We have optical sensors, we have a current sensor to measure power consumption and so on. These are tools that helps us to analyze the data as well as help the client to understand the real pain that they have. We monitor OE, we monitor quality, their daily labor productivity and so on. Another tool that we are using in the labor-intensive type of process, these are tablets. We give them to production team where they can conduct time study to their operators. As well as we have some of the advanced analytics predictive tools to understand the quality issues and so on. So all of this we do as a proof of concept, and it's free also for the client. Another thing that we do in the diagnostic phase, we conduct SIRI assessment. SIRI stands for Smart Industry Readiness Index, and it's an index that measure, let's say, your Industry 4.0 maturity level and how fast you can adapt it. It also helps us to prioritize some of the initiatives through covering 3 main building blocks. It covers your process, your technology, your organization across 16 different dimensions. The good thing about this index, it's not only showing us where you are and what are the things that you need to prioritize, it also benchmark the clients to a similar sector to understand where are the other competitors are going. Once the diagnostic is done, we understand the pain, we understand what type of levers that we are focusing on, we jump into the design phase, and this is usually 2 to 3 weeks. We are working together with the client to understand what are the initiatives that need to be implemented, what are the initiatives that need to be prioritized based on the impact and cost and so on. Again, this is another interaction session with the client. We work closely together to come up with a solid transformation blueprints. So what we have done so far, alhamdulillah, we have finished almost 80 factories. We delivered 80 different transformation blueprints in more than 15 different sectors in 9 geographic locations. In the beginning of the program, we focused only on the 3 main large cities. Now, alhamdulillah, we are able to have 9 different cities, including Khamis Msheid, Jubail, Yanbu, and so on. We finished 2 phases, and now we're working on the phase 3, the 3rd phase. Phase 1 was awarded to GE Digital. They were our consultant expert in this matter. And so far, we have identified more than 380 million impact for the clients who implement the initiatives. Phase 2 was awarded to McKinsey. The only thing that I want to highlight here is that on average, there are about 5 million Saudi Riyal impact for the clients if they would implement the initiative that we identified together. It means that the market is ready. There is a huge opportunity to implement such solutions, and the impact is there. We have so far conducted 7 training sessions, 7 boot camp, and we were able to train more than 500 employees of the factory that we work together. These are some of the impacts that we've seen so far. I have 3 success stories I would like to share with you before we end up the session. This is one of the clients who implemented some of the IoT solutions, optical sensors. After almost a year, we saw an impact of almost 45% on their OE. There was an improvement, which results into 10% EBITDA impact. Another client who implemented real-time cycle time for the labor, which resulted into almost 25% on their financial. The last client who we helped them to implement some of the to automate their design process. This resulted into about 25% of the improvement in minimizing their scrap, which results into 15% EBITDA impact. I have a couple minutes to take question. If not, I would like to thank you for this opportunity. تفضل.
It was a result of implementing the lean, or it was a result for implementing the lean and some sensors digitalization in the factory?
Okay, impact you mean. So what we do is we start with lean, Industry 4.0 technologies, as well as operational excellence. So we cover end to end. So to answer your question, there are both. تفضل.
Yes, thank you for the presentation. Very impressive work. I'd like to ask about the number that you've mentioned for the impact, the plus 360. How did you exactly measure the impact? Was it theoretical, or that was after a while, after implementing the project? The second question, how was the acceptance of the factories for this initiative?
First question, how we realize the impact. So we work together with the financial team. If I come to you and say that I reduce your scrap rate or defect, we will see whether this decreasing is a cost reduction, or it will, if there is a demand, then it will lock you'll sell more basically. And then we translate this with their financial team, and then relate to that to financial figures. This is a potential impact if they would have implemented the initiatives. It's not realized yet, but this is to show them that such value is existing. The second question is how the client is accepting those studies. It really depends on the maturity that we work with. So far, alhamdulillah, we did not face difficulties, let's say, but yeah, there is no, let's say 90% of the factory we work with, they accept the value or the pain, basically.
Thank you. يعطيك العافية على presentation. My question is regarding the process of the extra 300 factories that you're going to include in the new project. Is it going to be a specific sectors that you're going to cover, or are you going to have it the same that you have done for the 100 factories?
There's no, we cover all sectors.
Thank you.
Last question. Last question.
Thanks for your presentation. Like, the clients, usually when we connect the sensors, we are extracting the data, machinery data, and uploading to the cloud. So the cloud, it could be residing in Saudi Arabia, or it could be residing any part of the world. So is there any sort of a resistance from the industrial community? Like, do they resist passing on this very vital information to the cloud?
Yes, yes. We've seen some clients that said we cannot accept such solution if it's a cloud and it's outside our premises.
So are there any policies coming up from your team or from the government where to keep this production data and these are sort of things? Are there any?
I think there are multiple subjects around that, but so far I'm not sure where we are in terms of that. But definitely there is something that needs to be addressed. But what we do, again, we're working with a solution provider. Once we finish with the pilot, all the data is erased. So it is on the client's control up to the moment that we disassemble those pilots.
Thank you.
Thank you. الله يعطيكم العافية. شكرا جزيلا.
Thank you, Abdurrahman. Tanafusiyya is a program that provides financing solutions to support the improvement of the current industrial base through technology and digitization. To know more, please welcome to the stage Mohammed Al-Abanwi from the Local Content and Productivity Department in SIDF.
Thank you so much. Please allow me to cover for my colleague Mohammed Abanmi. My name is Hamad Al-Mufiz. I'm from Business Development. We've been working on the program named Tanafusiya 3 years ago. And the reason of developing such a program is that SIDF saw the high competition for the local products between the local and imported products, as well as between the local and local products, as well as we saw the increase in production costs. The increase in production cost came from two main elements. First is the energy cost that's rising. Second is the labor. And for that, we have came up with a program that supports our clients to come up with solution and to solve the two main challenges in increasing the cost, either in energy or in labor. And that program we call Tanafusiya. So the Tanafusiya, as my introduction, will cover two main sectors. The first is the energy efficiency applications, then financing the digitization and Industry 4.0. So let's go deeper in energy efficiency. Energy efficiency is to enable industrial manufacturers to increase their energy efficiency and reduce their energy costs. The main thing that's the applicants for this program that they need to submit is simpler than the regular project finance that's covered by SIDF. So what we're looking for to apply for this application is it's open for new and current clients. Brownfield projects, you have to have a project implemented and commercial working on ground. Projects, this application should have a reduction in energy consumption and costs, commercially proven technology, feasibility study, and reasonable CapEx and OpEx projection, as well as we implement other SIDF terms and conditions, as well as. The same prerequisites for energy efficiency would apply for the digitization. The aim of digitization is to improve existing manufacturing based on through technology implementation and digitization, as it's the name. The prerequisites are the same, but proven technology to reduce the operation cost and increase the efficiency. There are no more detailed slides here. We want to have it higher level and open the door for questions. But what we offer to our clients in this program, first, the main thing is the SIDF have a requirement for the sectors that we cover. So we don't cover all sectors, we have closed sectors. But within Tanafusiya, there is no limitation for the covered sectors. So it's open for all SIDF, all NIDLIB sectors. The second thing, we give longer tenure, minimum 7 years to the clients. We give extended grace period up to 24 months since the commercial implementation. And the main thing that's have changed this year is the financing coverage will be up to 75% of the project cost. We have secured the board approval on it this year. And we give a fast turnaround time, up to 8 weeks, to reassess the application and issue the approval to the clients. In short, what's the differentiation between, in summarize, to know what's the differentiation between تنافسية and the regular SIDF offering is the sector coverage, as I told, as I said, that it's open for all NIDLIB. The project cash flow is the main constraint, the main assessing part for the project finance, but we give minimum 7 years regardless of the cash flow. We give up to 48 months, as I said, and the turnaround time is shorter than the regular application turnaround time for SIDF. Plus the financing will not be limited for location. It's open, it's covering 75% regardless of location. That's it, I guess, yes. That's it from our side. We're open to questions if we have time.
Shukran, thank you. Thank you for the presentation. Just some more understanding in terms of financing. What will the financing cover? Is there a specific remit? Is it metering? Is it specific projects? What will it cover?
So the financing is the project finance. So any facility want to improve their operation through digitization or energy efficiency, the project cost for the CapEx, and as well as some of the pre-assessment, pre-project cost for consultation and so on will be covered under this financing.
Okay, and a second question in terms of the energy, is there a drive for ISO 50001 to go hand in hand? Because that's an international standard that then drives management behaviour to ensure that energy management is part of the structure and the governance of the business. Is that driven in this or no?
So maybe I'm not the technical guy to answer this question, but what we're looking for is to improve, to reduce the cost of energy consumed through in the facility. So whatever that's proven and technology, reliable technology, I guess we will be covered.
Okay, shukran, thank you.
You're welcome.
How many projects and clients have benefited from the NAFSA program so far? Volume and value.
So, تنافسية since launched have not gained the expected attraction from the clients. Maybe because most of the clients most of these projects within the client through the digitization is small in size, so they tend to finance these projects through their financing system internally. That's why we changed the system now. We changed the program and we gave faster turnaround with lower requirements to increase and to encourage clients to come up with these projects. Even 500, 600,000 riyals will be looked at to be financed through تنافسية with less requirements and less paperwork. In over, I guess we covered projects around 800 million Saudi riyals.
Thank you, Mohammed, for the great presentation. So just to follow up on what you were saying over here, did the low interest rate in the last couple of years affect Tanafusiya's maneuver in the market? So it wasn't very attractive for factors to go into that, while as we're seeing higher interest rate, this will change? Is this the expectation?
I guess what you're saying will affect all demand on SIDF. All the demand in SIDF will be changed through due to the increase of the lending costs from outside the development fund, and Tanafusiya will be one of the applications. Anything else? Yes.
thank you for your presentation. During the period of 50%, did that period like meet the SID of expectation, or like why it's increased to 70%?
So what we did is we increased the coverage up to 75%. The reason is to encourage more manufacturers and more sectors to apply these applications with less demand on their financing system. Anything else? Thank you. Thank you for your time. Appreciate it.
Thank you, Mohammed. His background is industrial engineering with a working experience in the manufacturing sector for the last 9 years in different roles with Ma'aden, Mudun, and GE, focusing on lean manufacturing and digital transformation. To know more about process-oriented perspective on the data to achieve digitization, please welcome Mr. Mshari Al-Sawan.
Assalamu alaikum. Good morning, everyone. So my name is Mshari Al-Sawan. I'm the Senior Business Development Manager within MENAT region for GE Digital. Hopefully shortly we'll have the presentation up and running. So thank you for being here. Thank you for the attendance. I see there's a scarcity in these seats, so this is always a good sign, basically. So before we start and before we talk about digitalization and so on, let me give you a brief about GE Digital and our portfolio, basically. So I'm still new to GE. I have been here for about 1 year so far, so I'm still learning about the different businesses we have. So basically, we're a huge organization. So when it comes to the different businesses that we have within GE, so GE is revamping its whole operations and the overall business for GE. So we were one of the fewest companies that is still a conglomerate, basically. We have multiple businesses in multiple areas that are not directly or necessarily related to each other. So at the moment, we're divided into 3 different companies. So we have GE Healthcare. So about 70,000 babies are born every day using our own equipment. We have GE Aviation, now going to become GE Aerospace. Basically, we are 2/3 of all commercial aircraft departures are run and operated by our own equipment and software. And we have GE Power. GE Power is basically divided into multiple companies and businesses, basically. We have the power business, where we're equipping 90% of all transmission utilities worldwide. We have GE Renewables, and we have GE Digital. So the GE Digital is one of the biggest industrial software companies worldwide. So we have we're more than $1 billion US dollars annual revenue company. We've been serving more than 21,000 customers all across the world, and this is through 4 different businesses. So we have GE Digital Grid, where 40% of all the electricity is managed by our own software. We have power generation, we have oil and gas, and we have manufacturing. And this is where I sit, basically. So within the manufacturing area, our software is running through about 40% of all manufacturing companies within the S&P 500. So basically, we have a well-established baseline, I would say, when it comes to working with manufacturers and with companies. And part of our customers is our own GE factories worldwide. So when it comes to GE manufacturing specifically, what do we do? What our offering, basically? So someone here just mentioned international standards, so I will start with that. So whenever we look at our own portfolio, we look at this pyramid over here, which is the ISA 95, which is this International Society for Automation standard when it comes to the level of automation. So we have here the plant sensors, we have the automation level, we have the historian, we have the MES, and then we have the ERP system. So all of these are linked together, basically. When it comes to factories in the kingdom, I had the pleasure of working with Mudun previously, so I would say you had a huge visibility on what we're doing overall and the level of maturity when it comes to the factories in the kingdom. So most of the factories in the kingdom will have an ERP system. It's not always an issue that we don't have an ERP system. You will always have an ERP system. But the ERP system is good for a company that is not running a shop floor. Because when it comes to shop floor, you're dealing with machines, you're dealing with assets. And in order to talk to machines, you need to enable them. While the ERP system is always focusing on things like finance, warehouse, HR, and so on, because these are statics, these are manual entries. It's not millisecond operations. But when it comes to factories, when it comes to assets, you're talking in the millisecond range. And in order to ask an operator or a supervisor to capture data on millisecond based on manual entries and manual observations, that's almost impossible. So, and this is where our solutions come into place. So Abdurrahman mentioned just before the implementation part. So I would say to the government, please don't go into that, just give us the opportunity. So in the implementation, we're always having issues when it comes to the connectivity. So in the MPP, the team over there always tries and gathers what is the baseline, what kind of operations do we have currently. And there's a huge lag in terms of the current maturity level for factories. The kind of factories that you're dealing with are not the SABICs or Aramcos of the world, basically. You're talking to a much smaller scale of companies. So they don't have the criticality of such sectors, I would say, and they don't necessarily understand the ROI behind that. So this is basically where our offering starts over here. So we're talking in level 0 when it comes to the plant connectivity. Plant connectivity is the foundation for any industrial software to operate. Without plant connectivity, you could buy a software, but basically it will not operate because the machines are not enabled to speak to you. So this is the first part and the most crucial part that we have to deal with when it comes to digital transformation in a factory. So we used to have a hardware business in GE. We used to supply PLCs and so on, but not anymore. So we usually rely on this on third parties, on our partners in the ecosystem, to go and work with factories when it comes to the automation, instrumentation, and so on. So working and dealing with the machines is not a simple task. So you could have machines with no sensors at all, no instrumentation, and so on. So you need to build that from scratch. You could have machines with PLCs. PLCs are locked. You are not able to access it, so you have to maneuver around it and so on. You will have PLCs that are out of date. It's not updated, or the OEM is not there anymore. So basically, there's always hiccups, I would say, when it comes to the plant connectivity. But once you build that, it's much easier for a factory to maneuver around. So where our solutions start, we start at the industrial gateway server. So each machine and each sensor and PLC has its own language that it speaks. So when it comes to our own offering for the industrial gateway server, we basically take all of these inputs, unify it in a single language, and then raise it up to the next level. So the next level here will be a SCADA or an HMI. SCADA is basically a data acquisition tool where you will be able to visualize the operations and get alarms and so on. So basically, it gives the shop floor huge visibility on what's happening within the shop floor. And then we go into the historian level. The historian is basically, the name is meant to tell you about the story of the product itself. So basically, historian is a data warehouse. It collects everything, all kinds of assets, all kinds of parameters, all kinds of tags, and store it in one place. So it's a single point of truth when it comes to the factory operations. And basically, it's similar to the blockchain in terms of the concept. What's in cannot be changed, cannot be played with. So this is a historian. And then we go into the next level, which is the manufacturing execution system or process plant applications over here. You could say that the MES is the ERP system of the shop floor. So the MES will take all of these data, all of these shop floor data, will try to make sense of it. It will give you the overall equipment effectiveness, where basically you're looking at the throughput, you're looking at the quality, and you're looking at the planning aspect of the assets, basically. And this is where the competitiveness could be measured for factories. So any factory, once you have visibility on its operations, if you want to go and baseline its operations based on the others, how competitive are they? So if we take P&G and Unilever, the comparison between them is what is your OEE level. If your OEE level is high, basically you're competitive. If not, basically your competitiveness is not that much. Over here, the MES basically will enable the interaction with the ERP system when it comes to the shop floor. So we're talking about planning the manpower, the resource consumption, the planning from basically optimizing the different machines that you have into the different orders coming from the ERP system and so on. So basically it has a holistic overview of all factory operations and how to optimize it and how to enable the decision making basically when it comes to factory operations. So how do we engage factories? What is the level of engagement? So the beauty behind such solutions is that it's not rocket science. It's not something that is new or emerging technologies. These technologies have been there for a long time. But what changed now is that the cost for you to go and implement is much, much more attractive. Because basically before, when it comes to building the connectivity for factories, enabling machines to talk, it was very costly. But now it's much more cheaper with the IoTs and so on. So the way that we engage with factories is as follows. So we knock on the door of the factory. They're interested in going into a digital transformation journey. So how can we start? First step is basically we go and understand what is the production stages that they have over there. So you have your recipe preparation, you have your filling stage, you have your packaging, and then you have your shipping. So at each of these stages, you as an operations, you as a maintenance, you as a quality, what kind of parameters are affecting your operations? What kind of parameters do you want to see within your shop floor? What kind of decision making you're going to make once you have these parameters? So basically, you start mapping the process and the different parameters that you have within that process. Then we engage our connectivity partners where they will go and walk into each single one of these parameters. They will assess the connectivity of these parameters. Parameters are there. You need a new instrumentation. The PLC is there. It's locked. It's open. So basically, we start doing a detailed assessment of what's the level of connectivity that you have within the shop floor currently. And then we go into defining the solution architecture and requirement. So I would say this is similar to what Modern is doing now in terms of building the blueprints for transformation. So we go into the factory. What kind of use cases do you want to solve for, basically? What are your pain points? What are your issues? And from there, we drive the discussion and we drive the business logic behind such investments. Once we build that, basically we reach the proposal stage and then we start the implementation. So I believe I had the pleasure of walking the whole journey, basically, when it comes to doing the assessments with Modern, then engaging with factories when it comes to Tanafusiyya. So I believe pretty soon 2 of the factories that we're engaged with will get the loans. So hopefully we will get our money once that happens. And basically we will build towards that. So I believe we took our time, or factories took their time in terms of building the foundation, building the know-how, understanding the reasoning behind going into digital transformation. And I believe the government did some good policies in order to push the factories to be more competitive, like the changes in the labor market and so on. So I believe this all will feed up to accelerating the level of implementation for factories. So just to give you a brief about what do we see when it comes to implementations, what will be the effect out of it. So we worked with multiple factories, thousands of factories across the world. So the impact will always go back to what is your baseline once you start the implementation. So worldwide, we saw about 15 to 25% increase in the OEE levels once we go and engage factories in such projects. But I believe in a lot of the factories that we have in the Kingdom and in the Gulf in general, that will be much higher. So Abdurrahman showed a couple of numbers for a couple of use cases that Mudun did while they're doing the MPP. This was by connecting one asset out of the total production line. So imagine connecting a whole production line or a whole factory. The returns are unimaginable for factories. So it's a no-brainer to go and engage in such projects. You will see a reduction in defects, you will see a reduction in the raw and work in process materials and so on. So there's a lot to gain once you go and engage in such projects. So with that, I would like to thank SIDF for their invite, and it's a real pleasure to be presenting in front of you today. And if you have any questions, I will be more than happy to answer it.
السلام عليكم. يعطيك العافية. My question is, worldwide, we've seen factories mainly go by themselves towards digitalization and transformation. So the incentive is built in them to perform these projects. However, the feeling, I don't know, correct me if I'm wrong, in Saudi Arabia there is still resistance to do these projects. There is still a gap to understand the benefits of these projects. What are the main reasons that keep factories in Saudi from applying these digital transformation projects? Thank you.
Thank you. So, if you tell me now to take you to one of the factories that we've implemented our own solutions in, I will not take you to a factory in the Kingdom. So this is one. So the problem is when it comes to the use cases are usually done on a global level. So when it comes to the baseline in the Kingdom and in the Gulf in general, you wouldn't find a lot of factories that went through that journey. And I would say some of the technology companies does not have the appetite, I would say, to go and spend a lot of time trying to sell these products in the region, basically. So this is the biggest issue that will not accelerate the process for factories to go and implement. So I believe what we're doing at the moment, and if you go to a company like الرابعة, for example, you'll be able to see how digital transformation affected their processes. But the teams that you're engaged with الرابعة, you're talking at a P&G level teams. So when it comes to implementation within the Kingdom, basically you have multiple aspects. First of all, the connectivity part is a big issue. So a lot of system integrators are working with government entities with huge projects, with huge commercial implications for such companies. So if you ask them to come with you and engage in a factory for 6-8 months, trying to convince the factory operations for a deal that is worth about 300K, they wouldn't go for it. So that's a struggle in itself. So the level of system integrators or the appetite of the system integrators is not great, and the technical know-how that you would need to have in a system integrator, basically you wouldn't find a lot of players that are there. And anyone who has an industrial background will usually be working with SABICs and Aramcos and so on. So the level of appetite is not that big. So that's one. And the other one is the awareness when it comes to the factories. So the factories are not yet aware
of the impact. So once you start building use cases, so the work that Modern is doing in the MPP is really great in terms of raising the level of awareness. So even though the factories or the program does not cover the implementation, it raises the language. So once you speak to factories now, the factories that I spoke to in 2008, the language is different now. So they understand the digital transformation, they understand the different aspects. They've engaged multiple companies. So I would say the coming years will have a huge boom in terms of these projects, but policy will have to drive this. Policy will have to drive the change and the competitiveness of factories. And I believe this is something that is very sensitive when it comes to governmental entities. But to be honest, for me, I would like to see more factories closing operations and consolidating the operations in bigger, I would say, manufacturing companies that are capable to drive the transformation, rather than have hundreds and hundreds of, I would say, small-scale factories or workshops in multiple cities that are not competitive and does not have any foundation to be competitive in the coming future. This is a long version of the answer, but yes, that's it.
Assalamu alaikum. Yeah, thank you for the presentation. My question, related to the model which you have shown with the ISA 95 and the different levels which are been there, from the layer 0 to the ERP. Yeah. As we have been seeing that, this model has been there since 70s in the 20th century. Yeah. So how we have been relating this one to the Industry 4.0, and as we've seen it up, under the Industry 4.0, it's been talking about with AI and ML, and also the pyramid is mostly diminishing, and from the level 0 to up to the level 4, the different components can talk with each other directly wherever the information they require and they needed. Yeah. So how you see that, the approach, which industries which are already been there or at this level, so for them, and what the way it should be, and mostly I see that means this level is applicable only to the industries which are not been even on the Industry 3.0 also.
Exactly.
Yeah.
So thank you for that. So basically, when it comes to the maturity level, I would say, especially your average Joe when it comes to factories. So this level is not there yet. But without this, you cannot go to the next level. So when it comes to AI and machine learning and so on, you would need data to make sense of things. You would need data to build the models, to test the models and so on. But at the moment, you don't have data in factories. So to speak to them at that level, for me, is the wrong approach, because they don't have the foundation yet to go into that level. But if you go to well-established companies and critical infrastructure areas in the kingdom, petrochemicals, oil and gas, this has been there for a long time. So they don't need to go and do it again. They need to engage directly when it comes to digital twin projects, AI projects, and so on. They're at that level. But I believe unless SIDF is planning to loan Aramco pretty soon, I don't believe that will be much relevant for the discussion with the factories. So the factories that are in Mudun will not, I would say very few of them already reach this stage. So they need to go and to the other level. So for us in GE, we have our own offering as well and solutions when it comes to after this stage. But basically, I don't believe a lot of factories are ready yet to go into that. And we're engaged in discussions with a couple of the factories that we think are ready at this stage to go into the next level. But for most of them, I would say more than 95% of the factories, if not more, are still, they need to do these stages before they engage into any AI or ML discussion. And the problem is, this has been pushed in terms of buzzwords and so on for factories, but when it comes to the reality of things, if you have 3 years of data, a machine learning model might not be sufficient, I would say, to go and have the right level of accuracy when it comes to operating such systems, basically. So you need to build a huge amount of data to make sure that whatever models you're going to build later on are really based on reliable and well-placed data. But this is why ML and AI, you will never hear it from me in the coming years. But hopefully, as we approach 2030, there you will have the discussion. We're seeing a lot of investments now in the automotive area. The automotive is by design, it's competitive. By design, you have the foundations. By design, you're going to design based on this. So I believe this is where you will see a lot of, I would say, adoption in that level. Thank you very much. Any questions, gentlemen? Ladies and gentlemen? Bye. Thank you very much.
Thank you. Thank you, Mshar Swayan. Wissam Al-Zamil is the head of cybersecurity at Context, a joint venture between Saudi Aramco and Cognite. She's a member in various of industry communities, including the World Economic Forum's Oil and Gas Cyber Resilience Group. Another guest is Peter Narvis, is a senior data scientist in the digital transformation team at Context as well. He specializes in digital transformation and in the industrial space, where he leverages data ops and builds data science solutions to tap into the vast potential of data to solve industrial businesses challenges at scale. To know more about data ops to power industrial digital transformation, please welcome Wissam Al-Zamil and Peter Narvis.
Assalamu alaikum. Good morning, everyone. This is Wissam Al-Zamil from Context. It's a pleasure to be part of the November, where Peter and I are very pleased to share a dear topic to our heart, which is data ops. First, I'd like to introduce in one slide Context. While Context might be a new name that is not familiar with Saudi Arabia yet, but it comes from very strong roots. So we are a joint venture that combines industrial expertise from Saudi Aramco side, as well as Cognite, the first unicorn in Norway that basically specialize in data and industrial domain. So together, we are basically have a dedicated vision, turning data into opportunities. And in the next slide, I'll show you the three main strategic alignment that even were the basis of how this company was got established. Context, just in a nutshell, we're basically a technology and service company. We specialize in data, cloud, in particular Google Cloud, as well as the digital industry transformation through the Cognite Data Fusion or the data ops, which we're going to explain in detail by my colleague Peter later on. So we'd like, as Context name entails, we like to put things into context. So moving backward, why we are talking now about Industry 4 and digital transformation. If you look into the 2030 vision, which is basically the driver for many transformations that we are living and witnessing today, it sets one unique goal or a unique objective, which is basically to develop the digital economy. Mshari, in his presentation or in his answer to one of the questions, highlighted many challenges related to technology availability in the kingdom, or even infrastructure, be it cloud or what have you. And this is the main driver for the digital economy. We are witnessing today many of the efforts, be it on policy level, be it on incentives such as Tanafusiyya and other programs, and be it on making the kingdom attractive for local and global investors. And one unique example is our partner Cognite, where we have the data ops platform localized in the kingdom, as well as our strategic partner Google Cloud, to also prepare the infrastructure required to help the industry even digitalize. The next program that even shows the commitment of digitalizing the industry is NIDLIP, or the National Industrial and Logistics Program, which basically has a unique effort or unique program to accelerate 4IR adoption, and basically to make the kingdom a global powerhouse, tapping into the IR4. And lastly, the very interesting and ambitious strategy that was launched weeks ago, which is the National Industry Strategy, which also aims to export very high-tech products from the kingdom. And if we want to do that, we need also to leverage these technologies in building such products domestically from Saudi Arabia. So keeping all of these in mind, we have also another main driver, and specifically of particular relevance to the industry, which is the net zero commitment, which is what the Crown Prince, His Royal Highness, announced to achieve net zero carbon emissions by 2060. And to achieve that, in our review, we need three dimensions. We cannot adopt technology alone, and we cannot adopt technology just because it's a buzzword. It has to be purposeful utilization, and this is where we need to start from the business challenge first, and then identify very specific use cases that we can measure the value added, the return of investment, which is many of the audience here maybe have tackled as well. And then you need to go on a very full-fledged program to scale it across many factories or even to combine and consolidate. And then adopting technology alone, specifically emerging technology, will not work alone. So we need a massive transformation. We are talking here not only on your specific factory organization, it's even driven in the business model, how the sector operates, how the authority interacts with the consumer, with the business provider, as well as in the end-to-end processes around that technology. So you cannot keep introduce an emerging technology, but keep your legacy processes as is. And then the cultural and behavioral shift, and I'll explain it also in the next slide. So this is one of the, let's say, main obstacles of why pilots could stop at specific stage, or even why even other organizations, they don't even change, because the management of change was not practiced. And people, specifically industry, they are very cautious. We are operating mission-critical operations. Sometimes it impacts safety, environment, health, and people, they don't want mistakes, or even the risk appetite is not that wide. So people will not maybe have that tolerance to go and adopt something new they are not used to. I heard a question from that side on why we are not seeing a lot of, let's say, adoption of 4IR technology. And as a company that we provide technology and services, we are summarizing here what we have seen, and specifically industrial clients, why they don't maybe even get interested in adopting 4IR technology. And just as a disclaimer, we don't think these are a showstopper, but these should be taken in the other way around, as factors that you should embed on your digital transformation strategy or even your business plan to ensure that they don't even become an obstacle to you. First, industry's complexity. When you compare the pace of organizations who are IT focused and an IT and OT industry, you can see the pace is very fast for their organization. In IT OT side, we are living with very legacy systems and a hybrid of legacy, modern IT, and then the emerging technology that gets adopted by the IT side, forgetting the OT side. And here comes a very interesting dimension also on the infrastructure, when someone from the audience asks about cloud. So technically speaking, awareness is key, specifically for industry. We've seen the cloud-first policy. We've seen the technology policy released recently by the DGA, the Digital Government Authority. And you have the license scheme of public cloud by the CITC, or the recently named Communications, Space and Technology Commission. So there is a maneuver, there is a way that organization can leverage public cloud in the kingdom, of course, once they know the data, once they know exactly what they are outsourcing to the third party. But again, we are living in a very risk-averse industry that need awareness and need to know exactly what kind of mitigation controls they need to introduce whenever they introduce such digital transformation projects. The second challenge is change management. So again, coming back to the value. So the easy way to overcome resistance is through pilots. Industry should be able to at least become more comfortable doing POCs, doing pilots, so they can understand the optimization, the efficiency, the return of investment, and they would be able at least to weigh out the risks and be able to adapt it faster. Next, I come from cybersecurity background, and I'm with digital transformation. So data and cybersecurity, we even hear it as like roadblocks that comes from the client, while we know that everything is risk management. Any decision in the business, including things that touches on infrastructure or in data, it could be managed. And even for cybersecurity, I come also from Saudi Aramco prior to Context, and we've done a lot of digital transformation revolutions in the industrial sector, of course, with very, very meticulous assessment on the risk and the mitigation controls, and of course, keeping in mind what data and what resilience factors that we need to put in place. Another challenge, also as mentioned, I believe also by Mshari, is talent and expertise. Sometimes it becomes very costly if we're going to rely always on a global expertise to install, configure, but the architecture, consultancy, and even the maintenance and support afterward. So organizations that we're going to acquire a new emerging technology should, in parallel, establish reskilling and upskilling program. So by the time you finish the POC, you already have your own staff are capable to not only to manage and sustain the technology, but also to innovate, to go to the next leap of using that technology to the next use case, to the next basically integration of how you can unlock more using the same technology that you invested in. And lastly, which is something that honestly we've seen very good progress in the industry, which is the technology and service ecosystem availability in the kingdom, which is again one of the main challenges that hinder organization to adapt because it's mainly related to cost. So think of blockchains, think of any other technology, disruptive tech, that requires not only the software or hardware, the appliance, but even they need massive processing power. Cloud computing, computational computing, and all of these are being built as we speak right now in the kingdom. So hopefully within 2 or 3 years from now, once we see the hyperscalers up and running, and once we see more global investors coming through the regional headquarter program by MISA and many other incentives, inshallah this obstacle would be overcome. But again, these are the main driver that once even the incentives, the policy makers understand what we hear from the clients, even the efforts could be even more focused towards solving that. Now, when you go also to NIDLib, this is the definition of, or at least the categories of Industry 4. As we mentioned, we are big on data, and we see it honestly as a foundation. So as soon as, and even it was mentioned, so one of the main obstacles for IT, OT, or industry, 2 main things. Interconnectivity, so organizations who did not start the IT, OT convergence, it will be needed to enable many of the industrial IoT use cases. And then the data, and basically the much more work you do in data, the much more value can be unlocked. So technically speaking, this is not like a prerequisite, so you should not stop your digital transformation journey because you did not work on the data, but you have to work in parallel, because the more you work on refining the data and unlocking more value from it, you would be able even to utilize the other technology well. And in general, Industry 4, specifically for industry, and we've seen it in many clients, it has very proven returns, not only on dollar value, but even on safety. You can also, for example, inspection use cases. You can also minimize any risks to human life by replacing it with digital, be it sensors, robotics, and many others that could integrate very well with the diverse IR4 technology. And then enhance competitiveness. So as we mentioned, everyone in the kingdom is looking at the 3 pillars, the 2030 vision, the national industry strategy. So if anyone would, any organization would still be resistant to using Industry 4, they cannot compete in the market. The others would be able to optimize, become their products becomes much more cheaper due to the optimization and efficiency, and they will not withstand having a competitive edge over the market. Now, I think in the last 5 years, in every conference, you keep hearing the word data is the new oil, and no one questions that, but no one asks what is the refinery of that new oil. So how we can basically refine it, how we can, as you know, oil comes with diverse products, so how you can take that data, make information, make knowledge, make insights out of it. And in context view, we think it is data ops. And this is where the second part of the presentation by Peter will focus on. Data ops is not just a technology that you plug and play. It's an entire business transformation that tackles many factors, which will go in deep next. Just before I hand it over to Peter, I'd like to highlight, just in terms of data ops, if you have read Gartner, the 22 Hype Cycle report, which highlights the trends for the next decade, I believe, they have mentioned that data ops will fully penetrate the market in the next 3 to 5 years. Again, because everyone, when they measure the return of investment of all the buzz technology that they have developed, they will not realize the value because the data that enters the technology is very limited. And you need that foundational layer to unlock the utmost value out of it. And even for McKinsey and company, they have done a study on many data analytics projects adopted by organization. And they have noticed that 80% of the time of that and these projects gets spent on very repetitive tasks. Get the data, clean it, and put the quality, ensure quality of the data, which could be just solved by the data ops. And this was the recommendation that McKinsey gave to those organizations in its scope. So with that, I'll hand it over to Peter, and thank you for listening.
Thank you so much, Wissam. As mentioned, my name is Petter Narvis. I work in the digital transformation team in Context. So there is an enormous potential, value potential of the data in the industry today. World Economic Forum is estimating as much as $3.7 trillion that will be unlocked by 2025. Data will drive operational excellence. It will drive towards more autonomous production. It will enable new products and services in the industry, and will also disrupt and create new business models. In the consumer world, we've seen a complete disruption of how we use data. We have data in our hand wherever we want it, whenever we want it. We can get all the information we want. Industry has not yet had its iPhone moment. It's not as accessible as in the consumer world. So this is what we're used to in the consumer world, right? We just search for whatever we need with intuitive searches. Let's see how this works in the industry. If I want to find time series data for all pumps of a particular type which haven't been serviced in the past 6 months and their locations, how would I go about getting that in the industrial world? I would have to go into one system, find all the time series, which is the sensor data. Then I would have to go into another system, find the pumps, a third system to find the location, and then a fourth system to look at the service records. Then as an engineer or an SME, I would have to manually combine all of this information to get this, what is a very intuitive query. This takes hours, right? And why is the industrial world lagging compared to the consumer world? And Wissam touched upon this. The industrial world is very complicated. Data currently resides in a number of fragmented systems, locked into these systems, not communicating. The data is stored in data silos. You cannot access it. Additionally, the business criticality of making data-driven decisions is very different. If in the consumer world, if Netflix suggests the wrong video for you to watch, then you just don't watch the video. If this happens in the industrial space, it could have enormous economic consequences due to production shutdowns, and it can also cause safety hazards. So how do we tap into this value potential to unlock it? And it's no longer a question if we need digital transformation, it's rather how, right? And I just want to dwell a bit with this term because it's used quite a lot. But it actually consists of two parts. It's digital and it's transformation. And the challenging part here is transformation. Procuring software isn't hard. Employing that software to change your business processes, that's the challenging part, right? Change management, changing cultures, changing the way we work. What we see in the industry today is that actually as much as 70% of digital transformation engagements fail at industrial companies, and only 30% of them succeed. What we do see that is for most of those who succeed, there are a number of key factors that they get right. The first one is the top-down ownership and commitment to digital program. You need the commitment, you need the purpose, you need the vision from top-down of where do you want to go. The second one is this holistic digital strategy. You can't just have fragmented engagements running, trying out different applications, trying out different solutions. You need a holistic view on how to drive your digital transformation. Secondly, it's more about organization, culture, and people. For industrial companies, their way of traditionally working is very different from how we usually work with digital, right? This more agile way of working, failing fast, trying, it's very different from the industrial reality. Then you need the effective monitoring. You need to define what's success. Once you've set the vision, you need to figure out what does that mean when I get there, and then you can monitor progress. So you can see, am I actually going on this path that I've set out, or am I drifting from it? And then lastly, you need flexible modular technology and data architecture. So here the technology comes in. I'm not going to go into detail on all of this. The main takeaway here is 4 out of 5 of these are about organization, management, culture, people. Only the 5th one is technology. Once again, transformation is hard. Procuring software is not. So then over to data ops. Let's try to demystify this concept a bit. It's a rather new concept, and it also consists of 2 parts, similar to digital transformation. It's data and ops. It's short for data operations. Data ops is not just software. Data ops is a data management practice. How do you manage data in your organization? How do you get data from the data managers to the data consumers? And Gartner has a very good definition of data ops, and says data ops is a collaborative data management practice. So it's a practice. It goes beyond software, right? Focus on improving the communication, integration, and automation of data flows between data managers and data consumers across your organization. So it's about allowing those who need data to improve their workflows to extract the value of that data, empower them with the data in the organization. What we're seeing also, as Wissam mentioned, in the industry today is that these digital engagements across the industry is started without attacking the data problem, without proper data ops. And then these engagement, actually the SMEs or developers or engineers, they spend 80 to 90% of their time collecting and cleaning data, and only 10 to 20% of their time building solutions. This is extremely costly, right? Consequently, what that means is that most industrial companies start out POCs. They have hypotheses they want to test, they want to try out digital solutions, digital applications, and many of these succeed. They see that there is value in them. But then since they haven't actually solved the underlying data problem, operationalizing these POCs and making them improve their business processes becomes very challenging. Lastly, also then, scaling these, let's say you build a solution for a particular equipment and you want to scale that across your fleet. If you haven't properly handled the data management, that becomes extremely challenging. So actually getting return on investment on these digital engagements, very few of these POCs end up like that because the data problem isn't solved. So this is typically how it looks in the industry, right? You have your source systems, the fragmented source systems, equipment data, ERP work orders, time series historians, etc. And then you run your digital engagements, that being out-of-the-box tools, engineering tools, data science engagements, applications in the marketplace. And then without solving the data problem, you get these point-to-point integrations. These are very costly to set up and even harder to maintain. Right? You would have to maintain all of these, and when you want to scale these applications out, you would have to re-establish these connections to the source systems. This is how you want it to look. You want to have this unified data layer where you solve the data problem centrally through a data ops platform. Then you only do the integration to your source systems once, and then that powers all your digital engagements, applications, solutions, etc. So Cognite has developed a data ops platform called Cognite Data Fusion. And just to re-mention that, Cognite is one of our owners, and we, in Context, are resellers of Cognite Data Fusion in the kingdom and in which we saw. Can I get pumps with this information and that information for that pump? Right? Because all of this information is in the different systems. You need to unify it and contextualize it. Then you can make the data valuable, because now you have made it available and useful and meaningful to the data consumers. So then that being your engineers who wants to use industry standard tools, or they can use low-code, no-code just to visualize the data scientists who want to develop data science solutions, or standard in the industry applications. The data ops platform will power all of these engagements. Then step number 4. If you don't have reliable data, you can't use that data to change your business processes. You need to have trust in the data. So this is also more on the operations part of data ops. You need to ensure proper data quality, you need to ensure the security, you need to set it up for the governance models that you have in your organization. How is the data managed? Then, once you have all these 4 steps, then you have the data available, accessible, meaningful, and reliable. Then you can actually improve workflows, improve business processes. Cognite Data Fusion is a globally trusted data ops platform. It's deployed at more than 80 customers across the globe. And they're using this to drive their digital transformation. To mention a few in the region, obviously we have Saudi Aramco, which is we have a very special relationship with them being our owner, a partner, and the client of Context. And also, you see, we go across a number of verticals, and manufacturing is the focus here today. Although the applications are different, the data problem is similar across industry. So Cognite Data Fusion is industry agnostic because it sets out to solve the data problem. And then the applications can be built on top for the particular industries. I'll just mention a few examples. Let me see. I think we're good on time. A few examples from the manufacturing industry. This first one here is a Norwegian manufacturer who produces custom equipment and custom equipment parts for the oil and gas industry. They have used Cognite Data Fusion to drive their digital transformation. And with it, they have established their internal development team to create applications for themselves. And what they saw when they got to solve the data problem is they got a 5x increase in application development. It really speeded up their digital transformation. So much so that they actually created a new company just to develop digital solutions for the market. So we're seeing how data here enables new first operational efficiency and then new products, new services. Another example is Framo, which is a pump provider. The traditional way business model is to sell a pump, and then they on schedule come and test if it's working or not, and then you see downtimes because it's not predictive maintenance. But with the proper data management, they could move from this business model to a business model or a pricing that was driven by uptime. So they could in real time monitor the performance of the pumps and then price based on that. So you're aligning the incentives between the manufacturer and the client. So here we see how data can actually change business models. We have, I've now zoomed in a bit to sort of data ops. What is data ops? How does Cognite Data Fusion attack the data problem? So before wrapping up, I just want to zoom out a bit to what is it we actually want to achieve. And I just want to show a video for that. Do we have sound?
Ready or not, your industry and the world is transforming. Everyone expects more of your business. You have to grow, transform, lead, and do it all more sustainably. The race to become a leader in industrial transformation is heating up, but you already have everything you need to win it. That thing is data. The answers to all of your questions on transformation, innovation, and sustainability can be found in your data. You just need the technology to act on it. The driver's seats in this transformation are reserved for those who use data to make bold bets, who make data do more. Take your rightful place behind the wheel. Our technology will help get you there.
Then I'll just move on. What this and summarize a bit what this video talked about. It's we need to transform, right? We know from an efficiency perspective, from a sustainability perspective, we need to transform, and we need to produce more with less, basically. And what the conclusion here is, we want to make data do more. We want to leverage this untapped potential of data. And if there are three main things I would like you to remember from this presentation. The first one is sustainability and profitability are not mutually exclusive. We need to improve efficiency to be able to be both profitable and sustainable. And the way we do that is through proper data ops and through leveraging the value of data. We cannot be green if the bottom line is red, right? If your business dies, you can't be sustainable. Secondly, data is not just for IT experts anymore. We're moving away from questions like, how can IT get me this data, to how can I actually get this data myself? The data fluency, the data literacy of your workforce will just increase. You need to be able to empower the workforce with the data and give them the data such that they can extract the value out of it. Lastly, the time to transform is now. And for the businesses that have not yet started on their digital transformation journey, I can assure you that there are others who have. Thank you. Any questions?
You know, one of the things which I see in scaling up of capturing the data in industry is like we are extracting the data from PLC sensors, from SCADA system, from so many different. The problem is that the data format is not uniform, or rather connecting to a machine and pulling the data is a challenging thing. Like, are there any sort of a solutions that you have, or is there any proposal, like we can have not generic plug and play, a similar, maybe like 80–90% we can extract the data. Is there any sort of a solution?
It's a very, very good question. It also ties into the digital twin concept, right? To be able to actually create a digital representation of the physical reality. And to be able, we know that industry is different. There are similarities, but all facilities are different. So you need the flexibility to actually model the industrial reality in digital. So with Cognite Data Fusion, our data model is an industry-based data model where we have basic components such as a data resource type is an asset, or another resource type is a sensor or time series. And then with those basic resource types, we can model any kind of facility and create a digital representation of any kind of facility. So we're sort of building that up with the domain knowledge in a digital data model.
Okay, thank you. One more thing is, like you said, like you carry out POCs. What's the conversion rate of POC to the actual execution of a project? Do you have any sort of a statistics?
I don't have any numbers on conversion rates, but I think if I move back to I think this describes it very well. So POCs are also a way of testing hypotheses, right? Testing if it's in the word proof of concept, and sometimes you're falsifying the concept. So sometimes it's good that the POC fails. You want it to fail fast. You want to figure out this fast. The problem is if you spend 80–90% of the time on collecting data, it becomes very costly to test out this. Other times you see that POCs succeed, but they're very hard to move into production, right? These steps, you see you lose a lot of them on the way. And that's because of the data management, the challenge to operationalize. So we see very few POCs moving into actually giving return on the investment.
And my last question, apart from Aramco, who are your clients in Saudi Arabia?
So in Saudi Arabia now, Aramco is our only client. Or you can add to that, maybe from the data ops perspective, we also have the cloud team. We're taking Google Cloud to the kingdom and are a reseller of cloud.
So currently we are, as I mentioned before, we are having 3 arms: the cloud arm, Google Cloud, which even CDF is even brought as a SaaS layer, so it will rely on Google Cloud. So this will even reduce overhead from the consumers to try to even scale their IT operations. We are now in discussions on the strategy side for digital transformation with multiple clients in Saudi, but it's not, we cannot disclose names. But hopefully once we mature in terms of we know what's the business challenge they have, we can start POCs with them and hopefully it can scale.
Thank you. Thank you.
My question is related to the solution which you are offering. is it a cloud-based solution only, or it is also offered on-premise, on-site? The second question is related to how the data is being from the shop floor. It's been pulled it up into the system, and usually the hard part, as you mentioned, that is how you relate or map that data into the different models and then contextualizing of that information. So how your software helps under that to reduce the engineering work which is required. And is the solution is based on any of the technology with, it has any self-learning built into it that which can over the time, to realize that how the information is being getting into the system and how they are been relating with each other so that it can predict that this information is being related to that part of them.
Yeah, I believe there was 4 questions there, so let me try to answer them one by one. Yes, it's a SaaS product, a cloud product. That's the short answer. With Aramco, with our special relationship, we've also deployed it on-prem, but it's a SaaS product on cloud. That's how we go to market. The second question was how we pull the data out of the source systems, right? So if you want to have a reliable digital representation of your physical reality, it needs to follow the dynamicness of the physical reality. So you need to automate the extraction, right? And therefore we have developed out-of-the-box extractors connecting to a wide range of the source systems that we see in industry. So we could just configure those and then pull the data out continuously. Also, we're API first, so for more particular systems, we can create these integrations through our API. Third question was about contextualization, right? So that also needs to be automated, right? You need to keep these relationships between the data from the various source systems up to date all the time. So we have automated contextualization pipelines. These are machine learning, AI, and rule-based algorithms that are running to make these relationships. And these are also learning as they go based on the data that they have, finding the correlations in the data and creating these relationships. Did I answer all of your questions then? Or?
We'll have the last question for Dave, please.
Thank you. It's more feedback than a question. I've been involved in digitalization for a few years now. And what's interesting for me is your presentation today is probably one of the best I've ever seen. And I'll explain why. It's because some people will present all the advantages, what the benefits are. They won't talk about initial cost. They won't say about some of the problems that you will encounter along the way, which you've done. And you've said that you need the management engagement, you need the leadership engagement, you need to have lean capabilities within the plant. If you haven't got those, it doesn't make any difference what you do. The sensor doesn't know it's a sensor. The information doesn't know it's information. The only people that know that are the managers, the operators, the leadership team who are running the business. So to show that and highlight that, but also have answers to that was very, very helpful. And I think added a lot of vision to where we needed to go. So thank you so much for that. I thought it was very good. Thank you.
Thank you so much.
Thank you so much, Wissam and Peter. And thank you, dear audience. We will have a 10 minutes break, and we will get back to it. Thank you so much. Welcome back. We would love to invite Wissam Zamel and Peter to the stage. A PhD in Industrial and Systems Engineering and 2 master's degree in Quality and Statistics. Currently, he's working as a professor in the Department of Industrial Engineering and a deputy head of the Innovation Unit in STEM at King Saud University. He's also a member of the Board of Directors of the Saudi Data Science Association. He worked as a data and AI consultant at several private and governmental entities in the field of education, energy, healthcare, and manufacturing. Please welcome to the stage Dr. Majd Al-Qahtani.
السلام عليكم ورحمة الله وبركاته. أهلا وسهلا جميعا. First of all, I would like to thank you for inviting me at CIDF for today's meetings. So today I will present a topic that is related to the AI in manufacturing. We will discuss about opportunities, application, and some challenges. So here is an overview of my presentation today. So we will introduce a little bit about AI and what is the definition of AI in the manufacturing sector. Also, we will discuss about the business growth in the manufacturing, and we will discuss about life cycle of the AI project and the architecture of AI, and also we will discuss some of the top use cases that is used in manufacturing, and we will also mention some of the challenges of implementing AI solution, and by the end of this presentation we will discuss some, or we will present some recommendation. So let's start with the definition of artificial intelligence. Usually when I define artificial intelligence or AI, it's composed of 2 words, artificial and intelligence. So artificial, it means it's made by human. It's not real. And intelligence, this is one of the characteristics of a human being, is to be intelligent, is to receive data, process it, and perform task and make a decision, and the decision will be made from a previous experience. So the human will learn something in the past and will apply this knowledge whenever we want to make a decision. So AI Our artificial intelligence is the science and technology that enable computer system, machine, or program to perform tasks that require human intelligence. So they will be able to sense, learn, infer, and decide. So let's discuss about why there is a trend in using AI in different industry, including manufacturing. So according to Kameni Research Institute analysis, the report saying that in Europe, Germany leads the peak with above 69 of its manufacturers' factories. They are implementing AI. They have at least one use case they use AI. Also, this followed by France, which is about 47% of the manufacturing, they are applying AI. UK, they are about 33% of the manufacturer, they use AI. Also in Japan, they have 30%, they are implementing AI in manufacturing, and US, there are about 28 of the factories, they are applying AI. So we can see a great trend of using AI globally. So why those factories, they are intend to use or to apply or to adapt the AI technology? So as we can see, will be an impact of the AI on the GDP of the country, like in general. So as we can see on the left side, we can see the bar chart that represent the GDP growth due to the use of AI in trillion US dollar in 2030. So as we can see, China, they are expecting around $7 trillion. It comes of the use or adaptation of AI technology by 2030. So also then we can see North America with less than $4 trillion and North Europe with less than $2 trillion, and developed Asia where the Middle East is located, they are expecting around $1 trillion comes from the enablement of AI technology. As we can see also on the right pie chart, we can see the contribution of AI in the Middle East GDP by industry. We can see the manufacture, energy, education, and healthcare, financial. And let's focus on the manufacture. It's projected that there will be around 13% increase in the GDP by 2030 due to the use of AI in manufacturing. So according to BWC, they said the Saudi Arabia is projecting to invest more than $135 billion, which is in 2030, and which is equivalent to 12.5% of its GDP due to the use of or adaptation of the AI. So with the introduction of the national strategy, national industrial strategy, where the main focus was to attract more investment, also achieve economic diversification, and developing more domestic product and non-oil export in line with the objective of the Saudi Vision 2030, we can see to attain the right growth, scalability, sustainability in manufacturing sector, there is a need to have more implementation, more leverage, more enablement of using the state-of-the-art AI solution. So let's focus here about the benefit, the value that when you start to think about applying AI, so what the value that will be attained. So first of all, we will have a better competitiveness. So the AI allows a better communication between the robot and the people to collaborate together to produce a variety of the AI or of the products. Also, this will give them a competitive advantage in the market to compete. Also, they have better productivity. As we can see, the AI will free workers to spend time on non-repetitive tasks like modification, designing, solving specific issue. So the AI can handle the jobs that has a repetitive task. Also, it will allow for better decision. The AI can help management to make efficient decision based on real-time data. Also, it's better communication. We discussed in the previous session about the interconnectivity, how important is it. So the AI will allow a better communication between the machine and to put all the numbers in a single dashboard, and based on that dashboard, you can build your decision. Also, the AI will allow for the better customer satisfaction. AI can help to predict the customer behavior and respond to the customer needs. So they can know exactly what they are looking for through chatbot, callbot, and other technologies. So now let's discuss about whenever we want to build AI project, what are the main steps that we should follow? So first of all, we're starting from defining the use case. So the use case is starting, so we have to have a clear definition of the use case that we are looking to solve. So we will define it in terms of the feasibility. Is there AI solution that is able to solve those problems or not? Also, we can see, or we can also need to analyze the strategic level that we will be attained from applying those AI technology. So we need to have ROI, the return of investment, to see how value that we are going to achieve by applying those AI solutions. Once the problem is defined and all the factors that involved in this problem are addressed, then we go to the second step where we need to access the data. The data need to be collected and processed in the right way. So we have different type of data. We have unstructured data, semi-structured, structured data. We have images, voice, text, numbers, signals. So all of this data need to be integrated into a single warehouse or a single source, so where we can call the data from there and do data analysis. So once the data is accessed and we have the right data and the data is available, then we go to the third stage or the third step where we identify the model. We either build the model or find the right model that is existing from the open library that is existing. So we can find the right algorithm or the right model, and then we train it with the data that we collected from the previous stage, and then we test it, we validate it. We want to make sure that the model is valid. So in terms of the performance measure, we can look at two things. We look at the accuracy. We need the result to be accurate. Also, we look at the speed and about the computational time. Sometimes you need to have a trade-off between the speed and also the accuracy. Once we find the right model, then we go to optimize the software ecosystem, where the goal here is to have the right integration between the database and the model. So also we need to do internal tests, external tests. We need to make sure that the model is ready to go live. Once we optimize the software ecosystem, then we determine the IT infrastructure. So are we going to save the model on-prem or on cloud? What type of cloud we are going to use? Are we going to use public cloud, private cloud, or edge cloud? So also maybe we have hybrid cloud. So we are going to decide that the right IT environment that will help us to have a successful journey of the AI solution. Let's go deep little bit into the AI infrastructure. So let's see, like we are going to, as we explained before, we have the 5-step. We should first define the use case, and so we have the production streamline, where the goal is to clearly define the problem. Are we going to have to build model for predictive maintenance? Are we going to predict the breakdown when the machine will be or the equipment will break down? So once we have, we can define or we can build use case based on the quality control, quality monitoring. If we need to check the quality of the product or finished product, does it meet with the standards or with the required specification or not? Also, we can demand or we forecast if we have supply and demand, we can build a predictive model that is able to have accurate forecasting. Once we define the problem, then we go to the second step where we access and process the data. So we have different sensors. So we can take an image, we can take a tabulated data, we can take videos, we can take signal. All of this data, it can be stored in a data sources. So the data sources can be database, any IT legacy system, SaaS app, application, web services, files. All of this can be connected with the IoT gateway. So to connect all of the sensor, and then we are going to have to process the data. The data processing will have 3 steps: extract, load, transform. So the goal of extract to integrate all of these data sources. They have different format. They need to be unified. Then it's going to be load in the data lake, and it's going to be load with their it's as a raw data. So they will be closed to be transformed. So whenever we want the data, it's always available in the data lake. And then we go to transform the data. So we need to make sure the data it has high quality. We need to check the validity of the data, the accuracy of the data, the completeness of the data. And also we need to make sure the data is consistent. There is no missing data, no repetitive data. So all of this, it can be checked. So the data need to be cleaned in order to feed it to the model. So once we go to the third and fourth stage where we identify and test the model, so we have the option whether we want to build the AI model or we want to just visualize the data. Also, we can think about data sharing, share the data with other departments. Also, once we build the AI model, then we are going to the last step, which is deploy the model. Are we going to deploy it using dashboard? Or also we need to, what type of integration that we need to take? Sometimes we need to do some type of integration whenever there is abnormal or there is the process is out of control. They need to send a notification to the right people to do action. Also, we need to build a dashboard. This dashboard, it can represent the previous data and also the current data and also what the data will be in the future. So all of this, it can be a single dashboard so you can have a full control of your factory. So now let's discuss about some of the top use cases of AI in manufacturing. So this is, so according to the IoT analytics, so this is the top 3 use case that is, it's proven that is succeed in manufacturing. So the first one is the predictive maintenance. So there are different solutions or different companies, they are providing a solution for predictive maintenance. Also the quality inspection and assurance, and also manufacturing process optimization. So as you can see, those 3 top use cases is equivalent about 60% of the total use cases globally. Also, we have supply chain optimization, AI-driven cybersecurity and privacy, automated physical security, resource optimization, automated data management, smart assistant, and AI-driven research and development. But let's discuss why those 3 use cases are succeeded. So let's see here. So we can see there are 4 reasons what make those use cases to be succeed. So clear business value and benefits. So it's already clear. Someone already take the initiatives and already apply it in his factory. So this is, and if he succeed, then our other competitor will follow him. Someone take the lead. Also, relative easy of implementation. So since it has a huge, there are a large number of solutions is existed in the market. So it's become, in terms of implementation, now we have solution that is easy to be implemented. Also the availability of the data. So the performance data from the machine and equipment for intelligence machine. Also we can take picture and videos from the finished product for the quality. Also the availability of the know-how and existing standard solution. So all of this, the 4 main reasons that make those solutions succeed. So let's discuss a little bit about the challenges. What are the challenges of applying or implementing AI solution? We can classify it based on 4 challenges. One of them is the technical challenges, where there is a problem or some issues regarding the computational power. The AI needs some computational power, either on-prem or on cloud. Also the integration with local cloud. Sometimes there is a regulation that enforces you to localize your data, or you don't need to, or you cannot transfer your local data to be outside of the kingdom. So you need to comply with those regulations which issued by the NDMO, the National Data Management Office. Also the explainability. So some of the AI model, they are identified as a black box model, meaning that they are using mostly a deep learning model or neural network, where the feature extraction is done automatically. So they give you very accurate result, but they don't know, or they don't tell you why you went to this result. So they didn't give you the factors that led to this decision. So this is those model is not explainable. So they need to be transparent model that is able. So once you give you the result, you know that the rule that is led to that decision. Also, we have the resources challenges, limited research and develop. Some of the problem you didn't have existing solution. If you have R&D department, they can build that solution, or you can also outsource one of the IT companies to build those solutions. Also, a limited number of talent. So this technology is it's a complex technology, so you need to have the right people to run and manage those technology. Also, we have some issues related to the data challenges. So the data quality and quantity. So you need to have the right quality. Whenever you have very good model with the data that is high quality, you will not achieve your expected result. Also, processing the unstructured data. Most of the data is identified as unstructured data, so you need to have the right process to how to structure, the right tool to structure to convert the unstructured data to be structured. Also, data privacy and security and bias problem. So the bias problem, some of the data that you feed it to the model that is biased. So it's not really represent the whole population. So you build a bias, at the end you are going to build a biased model. So you need to have unbiased model that is able to represent the whole population. Also, financial challenges. Sometimes you need to do a proof of concept, a proof of value. Also, you need to do the ROI in an appropriate way. So all of this is very important to get the right support, the right commitment from the leadership level. So here, as we discussed in this presentation, so we need to have the right problem. We need to define the scope, the strategic impact, and also the feasibility. Also, we need to have the right data. So this is in terms of data acquisition, data integration, data quality, also, and data security. All of this issue need to be clearly identified and addressed. Also, we need to have the right model. So we need to have the dual job and the model selection, model testing, and model validating. Also, we need to have the right process. This is in terms of model deployment. Are we going to deploy it on cloud or on-prem? What are the advantage and disadvantage of each mode? Also, we need to have a good data management and governance. So the data management and governance ensure the responsibility, also accountability, also transparency. Also, the data need to be transparent, and also we need to. So whenever there is an issue in the data, so we need to know where the issue is. So it can be done, or it can be achieved with a proper framework of the data management and governance. Also, we need to have the right team it's a team that consists of the subject matter expertise, data scientists, data engineer, software engineer, and data management and governance specialists. So once you have the right data, the right problem, the right data, the right model, the right process, and the right team, you will succeed in your journey in implementing AI solution in your organization. Thank you very much. So if you have any question, the floor is yours. Yes. Yes.
My question is related to, first of all, thank you. It was a really great presentation. As we have seen it up mostly, most of the companies currently, they are trying to sell their, products or the solutions that they are AI build or machine learning build. But as per the research, it has been found that most of those products, actually, they are being just the algorithms building up into those applications or softwares or solutions, but the real AI is not been there inside. So how, the question here is that means how the Saudi Arabia, the policies here, the government is can help to identify those who have been offering such solutions, that they are really based on the facts, and those products, what they are being describing, they have really that the features in it.
Okay, thank you for your question. So basically, the kingdom is investing in the area of data and AI. So this is why the kingdom established the SADAYA, which is the main entity for data and AI. And from there, they initiate the Saudi or the data and AI strategy. So the national strategy for data and AI, which is published in 2020. So where the goal there is and also in the strategy they have a KPIs, and one of the main KPIs, the kingdom need to be one of the 5 leading countries in data and AI in 2030. So this is very ambitious vision, and they have the roadmap to achieve this. So it's and also one of the KPIs they have, or they want to achieve more than 300 startups that is specialized in data and AI, provide solution locally, and bring the best like companies that is specialized in AI and data and AI to be in the kingdom. So this is to have so the goal of all of this all of this decision is to have, so the people here, the fact individual organization and also other entities, they have the right access to the model, so they have data, and they need have the right tool to utilize that data to get some opportunity, some value out of those data. So there is a trend, there is a huge investment in that part. So I think building AI model from scratch, it can be found in universities, or it can also find on the like educational institute. However, the other companies, they already built their AI models, so they have a well-organized model, so they can just plug it in with your data, and you can get the right result. So this is about the awareness. So which AI model that you are looking for that help, and it's relevant to your problem, and it's really what's going to solve your problem. Once you see the value out of it, then you are going to scale it up in your organization or your factory.
Assalamu alaikum. You mentioned in your presentation the rate of using artificial intelligence in some country in manufacturing sector, like Germany, like 64,
yes,
and other countries. How about the Saudi Arabia? Do you know what's the rate of using artificial intelligence in the manufacturing sector?
So I think up until now, I haven't seen a study or analysis on the implementation or the implementation rate on Saudi Arabia. But from what I understood, there is a trend now. Those factories, they see the value comes outside of the kingdom. Most of the factories now, they are thinking, or they are implementing the AI technology in their organization, and they get some value. It's an investment. Sometimes those factories, they feel like, if we invest in that one, what are the risks? How to mitigate those risks? And are we going to get value? So when we are going to return our investment? So all of this need to be, so take it seriously. So this is, I think, one of the objectives of the CDIF is to initiate those programs like Tanafusiyya and others to initiate. So sometimes you need this kind of initiation, this kind of motivation to motivate those sectors, because once you find someone lead this one and have a successful journey of his pilot project or BOC, you can see that there will be many followers. They're going to follow him, and you will see the value comes out of in the sectors. Okay. يعطيكم العافية. شكرا لك. Thank you very much.
Thank you so much, Dr. Majdel. A mechanical engineer with a sense of entrepreneurship since his early ages, and after being exposed to manufacturing and design during his studies and work experiences, He realized that 3D printing is changing the industry norms with its huge potential. He decided in the mid of 2015 to start a 3D printing services company, and since then they have been growing rapidly. To know more about industrial 3D printing, please welcome Dr. Faisal Al-Amir.
السلام عليكم جميعا. يعطيكم العافية, and thank you SIDF for arranging this workshop, and inshallah hopefully I will add something beneficial to you all. Thank you for introduction, and actually I am not yet a doctor. I'm still an engineer, and hopefully inshallah with time I will be that. So I'm here actually to talk about 3D printing and our experience in Namdija, how we utilize 3D printing as a manufacturing tool. 3D printing is something is very well known for everybody now. However, 3D printing as a manufacturing tool and a production tool that is really part of our factories, this is still an idea that we didn't realize it yet. So my goal today is to explain how this tool can be used as a manufacturing tool, and how, or to showcase real projects that has been done, and they are being producing 3D printed parts today in Saudi Arabia. So just as an introduction, Namdija is a solution provider. We are providing solutions for our client to use the 3D printing in their operations or manufacturing facilities. So basically, and this is how I like to introduce Namdija. We are a solutions provider. We have a factory and we have more than 60 printers, but we are not manufacturers, because manufacturing itself is not the added value that we provide. What we really provide is the engineering and the knowledge how to utilize this tool efficiently. So we have been working in 3D printing since 2015, served a lot of clients until now. Thank you. So just to go back for this slide. So we are working with our client to shift their manufacturing activities from the conventional mass manufacturing, inventories, and long supply chains to on-demand manufacturing. And this is the huge difference that 3D printing is trying, and it's actually doing it. Changing the model that we are using today from manufacturing, storing, selling, and then delivering, to sell, manufacture, and deliver. So it's a totally different approach and a very different mindset that we need to have. Challenges that 3D printing is tackling actually is lead time, overhead cost, manufacturing flexibility, design freedom, supply chain reliability. I will talk about in details on these challenges. So the good thing in manufacturing is, in the modern manufacturing techniques, that they are really fast and really cheap to produce parts. However, to start this process, it is a very long process, and sometimes it depends on very long supply chains. So eventually we will have this bottleneck, which is lead time. Secondly, it will require a lot of investment in preparing tools, dies, molds, production lines to produce any kind of product that you think about. So it will be very difficult to change your product, to change your design, to introduce a new business line. So it's very difficult because there is a lot of overhead costs, there is a lot of lead time you need to invest. And this is what we call manufacturing flexibility. So you don't have any manufacturing flexibility conventionally. Fourth, which is design freedom. Anybody who really work in manufacturing, he knows that every manufacturing technique has its own limitation of what parts that can be manufactured. Some technical details like undercuts, like minimum thicknesses, maximum thickness, maximum mass. So these are design limitations caused by manufacturing techniques. 3D printing is here to solve these limitations. And lastly, supply chain reliability, which we already talked about. So to understand 3D printing, these are like quick facts about 3D printing. 3D printing is not a manufacturing technique by itself. There is at least 50 different kinds of 3D printing techniques that are different totally from each other. 3D printing can produce metal parts, can produce plastics, can produce ceramics, concretes, biomedical materials. There are companies that now sells biomedical material to 3D print with. And regarding sizes, some companies that specialize only in producing micro scale parts, and there are companies that produce 20 meters parts. So it is a very, very wide different kind of printers. Printers can start from as cheap as 1,000 riyal and it can go as much as 20 million and more than that. Lastly, 3D printing will not work by itself alone. So it is a technique, a new technique that should be integrated with the current manufacturing techniques and the current post-processing techniques. So when we 3D print something, that does not mean that it should be 3D printed as its final stage. We can 3D print it and then machine it as casting. We can 3D print it and then coat it. So this is something that we need to put in mind. So the holistic approach. So we have been working since 2015, 7 years currently, and we saw hundreds of different clients. 3D printing, it seems very easy because it's printing, but actually it's not something as easy as print. To really get the opportunities and to really get the benefits of 3D printing, you need to think about 3D printing from a holistic approach. Put in mind that every part that you 3D print today is 3D printed for the first time. So we came to a world that everything is machined or injection molded or casted. So when we want to 3D print this part, it is 3D printed for the first time. We need to think in a different way to really get the benefit of 3D printing. So we don't think that 3D printing is an alternative manufacturing technique. It's a new manufacturing technique that will enable you to produce parts differently. So that's why we think that applications come first and machines come last. So if you want to go to 3D printing, the first thing that you need to do is to develop the application and to make your proper engineering to really use 3D printing. It's not the other way, which is buying the machine and seeing how to use it, and which is really what we are seeing in the most of the cases. So putting machines, knowledge, design, softwares, mindset in consideration to really grab on the benefits of 3D printing. So to understand the opportunity of 3D printing, as I said, we need to think differently. Usually when we would talk with our different clients and customers, the only thing and the first thing that comes to mind is how much it will cost. So when we talk about cost, usually we consider the direct cost, which is the part cost. However, it is only a fraction of what is really cost you. And if you just go a level upper level and see the real cost of your time that you have invested and the opportunity that you have lost and all other logistics and costs related to it, you will only realize the cost that you are really paying. So this is just to emphasize, if we want to really understand 3D printing and use it, we need to think differently and we need to understand the real opportunity after it. So manufacturing a part usually will go through a lot of processes. If I say a part like a casing of this remote control will cost me 2 Saudi riyals, that's right. However, you need to pay maybe 500 or 300,000 Saudi riyals to get the first one. And you need to buy 1 million remote case to get it for 2 riyal per piece. So yes, you can manufacture 1 million parts. However, you will wait for 1 year lead time. 3D printing can manufacture, let's say, one printer will manufacture maybe 400 remote cases per day. In a year, you make the math, it will make a lot of remote cases. However, so it is a really different way of doing parts on demand instead of doing mass manufacturing and putting a huge inventories and overseas shippings to only get a part. So yeah, this is what we are trying to say is we need to see what is the real opportunity we can get to understand the real cost of 3D printing. I have here an example. I think it's a very good real case to elaborate more about what I am talking about. نجيب الطاولة هذه. So I believe that practical is the best way to deliver an idea. So this is a part that we get from one of the most conventional industries here in Saudi Arabia. They produce very conventional products. They are making these for at least 40 years. They never thought that they can take advantage of 3D printing. And this part is actually one of the most easiest part if you want to see it. It's like a tube connector. Our client has a real issue in having a very huge inventories. His inventory cost is 300 Saudi million riyals of different parts and raw materials. This is not the only part. This is only one example of the parts that he have. So to produce this part, which he needs about 15,000 parts yearly. Usually 3D printed will not be a solution because there is the engineering mindset that we need to change. So the question we ask, how can we make this part feasible in 3D printing? And we will show you how we did that. How to make these conventional parts feasible in 3D printing. So if you can see the design here, it is a simple part. However, to 3D print it, it's not an easy task. If we want to reverse engineer it and 3D print as it is, it will be at least 50 riyals in cost, which is in injection molding. It costs our client 13 Saudi riyals. So it will be never feasible for our client. From 13 Saudi riyals to 50 Saudi riyals, in any case, it will not be feasible. However, if we think in a new way, because we are making parts differently, and we can use our freedom in design, we can produce it in this shape, and we can make it for 11 Saudi riyals, which is 2 riyal cheaper than our client other original options. In addition to that, our client will not have to order at least 15,000 parts as a one single purchase order. Our client will not be binded for his for this single design. He can print 15,000 parts for maybe 100 different designs, for different sizes and for different materials. So we have been successful, alhamdulillah, to convert this part for one of the conventional industries here in Saudi Arabia who need 15,000 parts from this single component and make it feasible. The only reason that we think differently, we think about it in a 3D printed way. If we want to go conventionally, it will never be feasible. So 3D printing is feasible. The question is how we think about things and how we can design it and change it. I hope I delivered a quick and beneficial presentation. I have a lot of use cases. I don't think maybe we have a time to showcase it all. However, I will be open for any questions if you have it.
السلام عليكم. محمد البطاح، قسم دراسات السوق SIDF. سؤالي أول شكرا جزيلا على البرزنتيشن الرائع والجميل. طبعا كانت في مبادرة قبل كذا سنة أنهم يسوون البيوت بال 3D printing use it in construction. لكن somehow المبادرة ما نجحت يعني. فايش الاسباب؟ من ذكرت بعضها، لكن how to overcome this المشكله هذه، خاصه في قطاع الكونستراكشن. انت تتكلم عن small objects now، بس لما نتكلم على bigger scale كيف ممكن نتجاوز العقبه هذه؟ شكرا.
يعطيك العافيه. طبعا احنا اليوم الصبح جايين من اجتماع مع شركه وطنيه للاسكان. so it is still ongoing and it's still a feasible approach, but we need to invest in developing it. I think maybe the quick answer is because they wanted to use 3D printing as an alternative method. They printed the house as they really exist, so they didn't utilize it as an add value. That's why it's not still totally feasible. However, if they think differently and if they integrated 3D printing with conventional methods, so let's say for ceiling and for roofs, for slabs, why need to 3D print it? So if 3D print the areas that have challenges and the areas that 3D print can really give you an add value, and this is what actually they are heading to, is to have a hybrid model. أي سؤال ثاني يا جماعة؟
يعطيك العافية. شكرا. ماجد الدوسري من دراسات السوق. سؤالي هو ال 3D printer الابلكيشن حقته في الاويل اند جاز does it require certain certifications زي ال API؟ مثلا Aramco requires ال API for their equipment وال product spare parts to be certified.
Okay.
هل موجود هذا التطبيق على الماشين itself؟
Yes, actually, whatever applies for machining, for casting, for injection molding will apply the same for 3D printing. So the same procedures for qualification, for testing, for certification, for any manufacturing method, it will apply the same for 3D printing. And usually for the oil and gas example you said, the requirements are for the part itself or the application itself. It's not for the manufacturing method. However, there will be some details. Definitely there will be some things related to technology but usually it will define this will be defined based on the parts. So what is the part and what's the component? And maybe Dr. Hashim can elaborate.
Just because I've worked in this realm, normally parts are not API certified. The equipment is API certified. So the pumps, valves, compressors, those are API certified. The impellers, shafts, gaskets, mechanical seals, not API certified.
Aramco needs to go through the certification process, but the part that you, for example, valve needs to be API certified to approve the whole part by Aramco.
Normally Aramco takes the equipment, but normally when you work with Aramco parts, we're talking parts, they don't fall under the 9Com category. They fall under the CAT category. Basically, you're dealing with gears, pieces. Those have to comply with not API standards, but ASME standards, the different manufacturing standards, not so much the industry standards, because you're dealing with parts that are part of equipment. So that's how they do it. The same thing with SEC, Saudi Electric Company, same with SWCC. So when you're dealing with parts, you're not dealing with industry specific. That's the advantage of additive manufacturing, because you can go across different industries and not be too restricted with industry specific standards.
So I think Dr. Hashim make it very clear, but just to summarize it. So what Dr. Hashim is saying is usually API certification is for the equipment. However, for the component, which we are reverse engineering and manufacturing, they are not related to these like API standards. يعطيكم العافية جميعا.
Thank you, Mohandas Faisal. Due to our VP's schedule, we would love to do the photo taking right now, but we still have one more session to go. We'll start with Abdurrahman Al-Askar. Thank you, Abdurrahman. مشاري الصويان. دكتور مجد القحطاني. مهندس فيصل العامر. الدكتور محمد أبو السمح. Thank you. Our guest speaker is a PhD in computer science from University of Oxford, UK, 25 plus years of experience implementing enterprise software applications, a Saudi Aramco corporate applications consultant, and technical lead in digital transformation program. To know more about blockchain technology as an enabler of trusted collaboration in Industry 4.0, please welcome Dr. Mohammed Abu Samh.
I would like to thank Asma for the introduction. I'd like to thank the event organizing team for this, for their great effort putting this great event together. Although they kept me to the last, I will make sure that my presentation is not that dry. I'm very sensitive that you don't have presentation fatigue after so many useful and informative presentations. So my topic for the day, I'm here for two objectives. The first objective is to raise awareness about one maybe of the less known IR 4.0 technologies, which is the blockchain. And the second objective is to share with you some aspects of Saudi Aramco blockchain journey. So in Saudi Aramco, we have, you can say, a high appetite for investing in blockchain technology. And thanks to the management support and the team effort, Saudi Aramco was listed last year as one of the Forbes Global 50 blockchain organizations, along with Boeing, Microsoft, IBM, Daimler, Chrysler, and others. So today I will share a little bit of relevant experience, and I'll be happy to share any more details offline. Just to make it easy to follow, our presentation today will be divided into three key parts. First, we'll talk about what we call digital trust problem as the problem that blockchain technology aims to address. And then we will touch on some key components of blockchain technology, and then end with some key considerations. If you as an enterprise or as a company, you would like to go about adopting blockchain technology, what are the key considerations that you need to keep in mind based on our learning experience in Saudi Aramco? Starting with the digital trust, يعني no question that we are on the edge of digital transformation, industrial revolution 4.0. A lot of our speakers today touched on يعني different aspects of IR 4.0, where we have speed and connectivity, where we have data, huge data volumes that need to be optimized and consumed. However, I would argue that there is one aspect of the IR 4.0 that need special consideration when it comes to inter-organization collaboration. We have been talking, about factory, considering a factory or considering a manufacturing facility or considering an organization. But what about those transactions that run across multiple organizations? Customers, suppliers, regulators, banks. Can we think about those transactions? When we think about those transactions, we will soon discover that are certain what we call trust gaps. Let's take one example. So assume a very simple example of an enterprise requiring a service. For example, that could be maintenance of an equipment or building renovation. So that enterprise would go and contract that service with a service provider. So there is a contract, and the service provider will start delivering the service according to the signed contract. And invoice the enterprise to be paid through the bank. We can also assume that the service provider could subcontract some of the service. We could also assume that the enterprise would employ like a third-party inspector to ensure the quality of the delivered service. We can also assume that before paying the service provider, the enterprise need to ensure certain regulations when it comes to tax or Saudization or local content, and then the bank. So here we can see there is a lot of information exchange, and there are certain gaps when it comes to the information. So we have each party in the transaction has their own system of records. There is lack of transparency across the transaction. Each party looks into their own data. There is also a concern about the compliance to the contract and to the regulations, which can result in lengthy processing and verification time, and could also open the door for some disputes between the different parties. In Saudi Aramco experience, this is one of our typical use cases. We could, in some industrial organizations within Saudi Aramco, that cycle could take on average 40 days to be able to contract and the contractor delivered the service and get their payment. That could take on average about 40 days. With the blockchain, at a high level, those parties involved in the transaction would agree on to have the terms and the conditions of the transaction in what we call a smart contract that we will define later. So that smart contract will capture the logic or the terms and the conditions by which the transaction will be delivered, and also the data format. And whenever a transaction happens, it is verified according to that smart contract, packaged in a certain way, and saved in a shared repository. And we will have more details as we go along. But with that we can have a unified transaction log that all parties can view, and that can avoid disputes and optimize the processing and the verification time. So this is what we mean by digital trust in IR 4.0. And you can trace that problem in different scenarios. We just covered one of them, which is compliance to a service contract. We can also trace it back into when there is a supply chain of certain goods, or authenticity of credentials. Many examples, for example, a food supply chain where the consumer would like to ensure that the food being consumed is organic, for example, or has certain quality characteristics, or in drugs, where is the it is a matter of life or death to make sure that the supply chain catered for the right medication, or for example in high valued items like diamonds, or even in when it comes, for example, into digital certificates or credentials. So with that, I hope we have some level of understanding that when there is an inter-organization transaction, there is some gaps that need to be addressed by certain technology, and this is and the blockchain is introduced to address that gap. Before going deeper into the blockchain as a technology, let's have a quick look into how a blockchain transaction is done. So a transaction is triggered and submitted into a network. So we have a business network consisting of several nodes, and each node represents a business partner in that business transaction. As we will see, each node will have a copy of a digital or a smart contract that is digitally signed, and also each node will have a replica of the data that is being processed throughout the transaction life cycle. For a record to be stored in the blockchain, the different parties need to apply certain protocol, what we call consensus. Once the parties agree that the transaction is valid, it is stored in blockchain, what we call distributed ledger. And the distributed ledger stored, it is immutable, so that it cannot be changed. So basically, this is at a high level how a blockchain transaction is done, and from that high view, you can identify certain key components that need to be in place in order for that transaction to happen. Namely smart contract, cryptography, consensus mechanism, and distributed ledger. Again, without going into too much details, I'll just touch very quickly on each component, just to raise your level of awareness of how the technology works. Otherwise, in the blockchain implementation, all these components are embedded in a platform, and the solution is built on top of a platform. So smart contract is really an evolution. When blockchain started as a technology for cryptocurrency and tracing how Bitcoin is moved from one person to the other, that was the early version of a blockchain. With the smart contract, now we can trace any item of value. Whether, as we have seen, whether it is a service being delivered, whether it is a food, a medication, in the supply chain, any goods or services. So the smart contract is really the logic that provide for the logic, the program that provides for relevant parties to trace any item of value. So the smart contract can also be called by different parties in the platform. It is digitally signed. It is the agreed. You can compare it to the paper contract, where parties sign and each party has a copy of that paper contract. Similarly here, the smart contract is transformed into a digital copy, digitally signed, and each party in the network has a copy of that smart contract. The other component that blockchain technology utilizes is cryptography. All the data in the blockchain is hashed using what is called a hash function. And hash function, cryptography is a science by itself. A blockchain uses certain aspects of that science. There are certain key characteristics of the hash value. All the data is hashed and stored as hash values in the blockchain. The data is encrypted using public and the private key cryptography. So public keys are available in the network. Private keys are kept with the members of the network. And you can encrypt and decrypt using that combination of public and private keys. Finally, also cryptography is used. The data in the blockchain are hashed and it's stored in blocks, and the blocks are organized in a certain cryptographic way to ensure the data consistency and the data integrity, what is called the Merkle tree. We also touched about the protocol that the parties in the network need to agree in order to store a specific transaction in the network. And this is what is called the consensus. Consensus is determined whether it is a public blockchain or a private blockchain. So in the enterprise world, the focus is on permissioned or private blockchains, where certain business partners agree to establish a blockchain, and there are certain consensus algorithms followed in order to determine how the protocol will run to validate the transaction being submitted to the network. Finally, we have the distributed ledger technology. We can easily understand the distributed ledger as an example of distributed database. We are all familiar with centralized database, where we have a database owner who own the data, provide access to different users, apply certain business logic by which the data can store. So there is one owner, central owner, and there are different users or stakeholders. With blockchain, the database becomes distributed. So nobody owns the database, but everybody share it. So we have the partners or the members of the network sharing a copy a replica of the data being shared in the network. And that data is real time, so whenever a transaction takes place, it is distributed or synchronized into the different instances of the database. And we can also apply some privacy mechanism. It doesn't mean that it is shared, that everybody can see everything. There are certain privacy features that we can apply in order to apply authorization mechanism. And once the data is stored, it can never be changed, which bring, for the trust of the data. So that was a quick journey. I'm very sorry if it's a little bit dry, but I would like just to end with a few considerations if an organization would like to go in the adoption of the blockchain technology. This is a model from the World Economic Forum, which describe, at a high level, what are the key characteristics of a business process. The first consideration to keep in mind when you go into the blockchain adoption journey is what is the business process. The business process need to display certain characteristics. It should involve a transfer of something of value. It should have some like third-party trust providers that you would like to eliminate. You can agree with your partners on some shared repository, and you need to have transparency throughout the transaction life cycle. Just to give you a few examples from Saudi Aramco experience, in our experience, we have adopted blockchain from different angles. First angle is the build, where we have evaluated the technology. We evaluated the different platforms in the market. We identified a platform, and we start building solutions on top of that platform. For example, trusted invoice that I showed you at the beginning. And other example is the hydrocarbon custody transfer. So trusted invoice with the suppliers, custody transfer is with the customers. When Saudi Aramco provide hydrocarbon products to different customers, and there is a potential for dispute on the quantity or on the quality of the data, a blockchain was deployed in order to provide visibility and transparency throughout the hydrocarbon product life cycle. This is the first adoption pattern. Other way of adopting blockchain is to consume blockchain. So there are certain organizations who established blockchain technology and published blockchain services in order to address certain business needs. One of them is BlockCert, where you can use it to verify the academic degree of applicants. So it makes it easy to embed in your candidate employment process. You can call web services published by BlockCert in order to verify whether the degree provided by the candidate is authentic or not. Another adoption pattern is to join a consortium. So consortium are blockchain networks already established and available. For example, the Trust Your Supplier is one of the blockchain consortiums that help members qualify potential suppliers. So instead of each member of the consortium qualifying a supplier on their own, there is an agreement on certain procedures. And if one member of the consortium qualify a supplier, then other members can take advantage, reducing the process for vendor qualification. Finally, one of the adoption streams is to invest on some blockchain startups. And in Saudi Aramco experience, this is something we have also done, investing on some national as well as international blockchain startups and leveraged their new technology. As I said, we have done a lot of blockchain investment and adoption. I'll be happy to share relevant experience offline. With that, I would like just to highlight or to summarize some of the key aspects of this talk. Blockchain is a new paradigm for cross-organization. So here the view is about transactions that go across organizations. Blockchain enable what is called a shared ledger or a shared database that different parties can store data for the transaction in certain format and have transparency of that data. Also, parties in the blockchain transaction agree on what is called the smart contract, where the terms and the conditions of the transaction is automated and used to verify the outcome of the transaction. Data in blockchain is encrypted. To adopt blockchain, you need to select relevant use cases. Not any use case can be used for blockchain. And finally, it is a balanced decision between technology and business, considering that you need to go and agree with your stakeholders and to share with them a governance model and incentive that to join your newly established blockchain network. With that, I conclude my presentation. I'll be happy to answer any of your questions.
Thank you for the presentation. It's very interesting. You see lots of systems being hacked by different countries or different entities. What makes blockchain different for that, for other entities to hack it, to get the information, to use the information? Why is it different to every other methodology that we've currently got in circulation?
One advantage is, first of all, the cryptography. All the information is hashed. So when you hack it, you will just have hashed records. A combination of letters and numbers that will you will not be able to make any use unless you have the right public and private keys. The other advantage of a blockchain is that you have a network, and each node in the network has a copy of the data. So assume that, which is different than the central database. If the central database is hacked, then that can cause lots of damage. In the blockchain, if the blockchain is hashed, is hacked, then you can restore the data from the different nodes, because every node has a replica of the data in the network. This is what I could do.
Okay, so this means that you can't be held to ransom. This is your point, because you have that information in several different places. You just replace the information that's been stolen.
Exactly.
So it could still be stolen, but your comfort blanket is you have the recording information elsewhere.
Of course. Yeah, of course. I totally agree with you. But again, hashing and cryptography would provide some protection against that. Again, in Saudi Aramco experience, we apply all the traditional, security mechanisms on top of what blockchain offer for, cyber security.
Shukran.
Thank you. Thank you very much.
Assalamu alaikum. Thank you, Dr. Mohammed Al-Abulsan. It was excellent. You were saying like dry. I was like thinking, wow, what a wonderful topic we were discussing on. It's like, though we are talking on Industry 4.0, again, blockchain is one of the key things which we have to develop, communicate with many different machines and many different businesses and many more things. This we cannot ignore. Blockchain is one of the things that interests me a lot. And I assume quite a lot of our team members, they'll agree, not only this conceptual way, maybe in the Bitcoin, Ethereum and all, I know many of them, more than interested. So with this, we are at the last part. So for me, I'm more than happy. Thanks for all the speakers who have taken out their time, traveled to make this event happen and enlighten us with such a wonderful knowledge. Each of you brought something special, something unique, like blockchain, like the other one, like retrieving the data from machineries and all. So these are the unique experiences that we gain from those guys who are in the industries. We are pulling the industrial knowledge and giving it to SIDF community and to our core system which exists. It's this passion that drives building up community like what we have, what we are looking for, Industry 4.0 community. And this is what our vision is, to enable Vision 2030. These are the pillars. All our speakers are the pillars to enable and to be successful for Vision 2030. I thank them a lot, and I need a big thanks for them from our I'm sure you all have learned something new today. We are sitting at SIDF. You have the power to explore industries. I visit so many industries. My colleagues, they visit so many industries. We have the tons of knowledge. We expand our knowledge. We engage in our community. We commit to support each other. And we learn from one another. This is the quest which requires to achieve the Vision 2030. Again, and you have spent wonderful time, and I'm sure this time it won't be wasted. And the knowledge, I hope, you will spread out in SIDF as well as beyond SIDF to our clients, to business partners, and so many. Thanks for you all to spend your valuable time here. Thanks for organizers of this knowledge event, Mr. Ahmed Al Nasser, Yara Taha, Abdul Rahman Abdul Latif, Ibrahim Al Khalifa, and rest of the team members. A special thanks to our management. They have provided such a wonderful platform where we can exchange our knowledge, our ideas, and communicate and build our community. So for our management here, Mr. Adil is here, and few of them are off our auditorium. I thanks for them, and even to Mr. Adil. With that, I conclude here. There were a few things, like the distributions of our trophy should have been now. Because of our management commitment, they had to go. I apologize for that, okay? And then I wish a wonderful journey from here to start up Industry 4.0 and beyond. Thank you very much.